Hello, and thank you for joining this afternoon session. My name is Troy Whitney, and I work for Network to Code. Today, we will be discussing the business drivers for network automation. The benefits of network automation go well beyond the technology itself. With a comprehensive network automation framework, you can address a wide range of strategic business challenges, including rapid response to business requests, boost the reliability and availability of network services, reduce maintenance costs, as well as increase business innovation. But to fund these network automation initiatives, we often need to quantify and predict the return on investment for the business. In this session, you will learn how to associate investments in network automation with these and other business benefits to help you secure funding for the new initiatives and to document the return on investment with key performance indicators. Now, before we start, it's important to define the current state and common challenges with most enterprise networks today. Many of these challenges or inefficiencies offer some of the greatest opportunities for a rapid return on investment. If you would, consider just one or two of the top tasks that consume the most of your own staff's time and effort. Now imagine a world where you can automate these repetitive manual tasks and how much time you could give back to your engineers to pursue more strategic initiatives. Next, we'll discuss what network automation initiatives need to happen to relieve those challenges. Keep in mind that network automation is a journey, not a destination. It will take time to build a comprehensive enterprise-wide network automation framework. It is an incremental strategy. But if we can properly associate these tangible benefits with each step of that process, then you can measure the incremental value delivered at each phase of the journey. Finally, in the last step, we will discuss over a dozen key performance indicators that you may consider to measure the progress of your network automation journey. Using these KPIs, you can accurately measure and predict the positive outcomes and value delivered back to the business by your network automation projects. Now, to begin, as businesses strive to compete and grow, they will forever be asking for more from IT. New technologies such as virtualization, cloud, and DevOps make new business services possible and can make old services more efficient. The challenge for IT and network teams especially is to grow and support all of these new innovations while continuing to keep costs within budget and continuing to meet their expectations for a fast response time and especially high availability of network services. Now, if you boil it all down, IT teams are frequently looked upon to complete more work faster, better, and at lower costs than ever before. While at first these may seem to be competing goals, it is actually possible to deliver all four positive outcomes at the same time. Network automation holds great promise to reduce or eliminate repetitive manual tasks, to use standardization to drive out complexities, and increase reliability and timeliness of network changes. We'll discuss all of these and more in the topics that follow. So now let's identify just a few of the most common challenges to network operations today. Now, this first challenge is a perception problem for network teams. Many software development teams have adopted modern DevOps practices. These techniques bring software development teams together with the operations teams to iterate more quickly. They break larger problems into smaller bite-sized chunks and turn around new features in a time interval they call a sprint that may be as frequent as every 2 weeks. A network engineer once asked me, how could our network team do that? We can't even place an equipment order with a vendor in 2 weeks. Yet, all of these resulting software applications built by the new DevOps teams ride on our networks. Those software developers have become accustomed to using cloud APIs that allow them to quickly provision, tear down, and re-provision network services in the public cloud on demand. They do this using programmable network services. Now, is anyone here, do you know the mean time to close a network services request in your own corporate network? These times are frequently hours, if not multiple days, depending on the complexity of the request, the number of network departments involved, etc. So you can see the disconnect here. So the end result, this perception problem, is that the corporate network may be viewed as a bottleneck to progress. Business executives are asking why the corporate network can't move as fast as the competing cloud services do. Now, in some ways, this second challenge helps to explain the first one. Modern corporate networks are complex, having accumulated over many years of incremental growth. Not only have networks grown organically, but business acquisitions have forced networks together that were never built with the other one in mind. They have overlapping address spaces, disconnected security zones, and they were just built to different corporate policies, and were provisioned or managed by different tools, often from competing vendors. The network teams have also grown over time, with specialized teams created for different network technologies such as routing, switching, data center WAN, wireless. Each of these specialized teams has selected the best purpose-built tool for their needs, usually from different vendors. As systems were built out, knowledge and data has become siloed and fragmented across each of these teams. Now, as you begin to consider network automation, you will find that the vendors in each of these departments have started to build out automation features into each of their network management platforms. One difficulty you may find is that while these were good intentioned, the automation features built into those platforms sort of work independently without a lot of integration across departments. Now, with those two challenges explained, let's consider an example service request to stand up a new branch office. On the front end, a business user may use a service catalog such as Remedy or ServiceNow to submit a single request for a new branch office, but this is only masking the complexity that lies beneath. Behind the scenes, a more detailed set of service requests is often created with each of those specialized network teams to provision their equipment and services for the branch. Sometimes the creation of these subtickets is automated, but many times there's a manual swivel chair where a person copies data from the master service request over to each of these subtasks. Now, each of these teams will often have their own departmental data store. They use this to track usage and availability of resources. Think about IP addresses and subnets and so forth. Now, many of these subtasks have dependencies on other subtasks. They can't all be done at the same time or in parallel, and each subticket has its own SLA response time window. An enterprise client we work with recently explained that if you added up all of the SLAs from all these subtasks, they totaled over 18 months. Now, the business isn't going to wait 18 months to stand up a new branch office. The only way they can get this done is to assign a project manager to manually track down and complete all of these subtickets. Herein lies the rub: the resulting sprawl of the IT team and the frustration of the original requester. There has to be a better way to get work done. Okay, so let's begin to take a look at what needs to change to improve this situation, and also how to begin to associate business value to each of these network automation initiatives. So, all joking about network engineers and DevOps aside, the tools and techniques of DevOps are actually one of the foundational elements necessary for network automation. DevOps, as much as anything else, is a journey. You won't flip the switch and instantly be a net DevOps team. It's important to start with low-hanging fruit. Begin to experiment with using vendor APIs for programmable networks. Move up to Ansible playbooks or Python scripts to push your most common changes into the network. Over time, you'll want to adopt an API-first methodology to manage the network. You'll also want to begin to use software polling and analytics tools to measure the effectiveness of network automation. This data will help you make decisions about which manual processes you'll want to automate next. Now, DevOps isn't just about tools. The culture of DevOps really encourages more communication and collaboration across teams. After all, it's bringing the developers and the operations teams close together to find solutions for the business. It's also going to enable more timely troubleshooting and just a better end result for the client because the teams are working better together. Keep in mind the last diagram we had with all the departmental silos of each of the specialized teams, even within the network teams that have trouble communicating. We really need to find cultural ways to break down those barriers and start to build solutions together in a reusable manner. Now, a lot of what you're going to start to see across all of these different teams and all these different problems is design patterns that you can reuse. The reusing of these existing engineering patterns or design patterns is going to help speed development. It's going to increase reliability because when you start doing the same thing over and over with an automated tool set, you're going to drive consistency and repeatability into the solutions that you build, and it's ultimately going to result in better automated workflows. The last thing is really what we're all here to do, and DevOps is a foundational piece of this, is we want to provide solutions faster, more often, more reliably, and we want to align these with business requirements to help the business innovate faster and be more competitive. Now, this is when the fun can start. Once you've started to adopt DevOps methodologies and you're building programmability into your networks, you can start to plan for an enterprise-wide automation framework to bridge those technology islands together. And ultimately, this is the key to starting to really deliver value to the business when you start to integrate all of these disparate systems into one network platform with APIs that allow everything to interoperate. Now, ultimately, what you're going to be able to do with a framework such as this is start to break down each of those departmental information silos, where we showed on the prior diagram, we showed a local information database. It could be as simple as a spreadsheet or a Word document or something where they were tracking information for their departments. We want to aggregate all that information into an enterprise-wide source of truth, one authoritative source of all the data for each of the systems that now people can share and trust that that's the most recent up-to-date information. With programmability, with an enterprise-wide source of truth, with this enterprise-wide automation framework that bridges all these technology silos, we can really start stitching pieces together and start to look at self-service catalogs like ServiceNow, the ability for a user to go into a self-service catalog, request a specific service, even a complex service, and the network automation engines on the back end are able to leverage the programmability you've started to deploy into your network to complete tasks, especially repetitive tasks, via automation instead of the manual processes that we used to use before. All this is driving consistency, speed, and responsiveness into your network operations using automation. Now, the topic of an enterprise-wide automation platform is quite vast. We don't mean to oversimplify it here with the one slide you just saw. It's important to understand as your teams begin to explore automation, there's a big difference between departmental power tools and an enterprise-wide framework and enterprise-wide standard for network automation. Think about departmental power tools. They're often limited use by a small audience. Someone on your firewall team creates a small script to automate pushing rules into the firewall. They're inherently difficult and expensive to maintain in the long term because one engineer made some design choices on tools and design patterns and code and repositories that's really an island unto themselves. They haven't standardized that across other departments. So what ends up happening is it can be very difficult and expensive to maintain that because somebody else eventually is going to have to reverse engineer it to support it and repair it down the road. Often what happens is it's just left on the shelf and abandoned because people don't understand all of the thought that went into it by the original designer. What we want to strive for is an enterprise-wide platform that drives maximum consistency and portability across all of your departments and all your technology stacks. Now, what that means here is we want to build one enterprise-wide standard that everybody uses together. We're going to standardize all these departments on common developer tool sets, consistent versions of code and software, and we really want to provide for them reusable design patterns so they don't have to invent everything from scratch. We're going to build code libraries and different repositories where they can start from a jump start and not have to develop patterns on their own. Now, what this results in, which is really good for the business, is maximum information sharing, portability of engineering talent between departments and teams because they're all using the same standards. You could have a developer that one week they're working on firewall rules, the next week they're working on automation for load balancer VIPs, and the week after that they're working on SD-WAN automation. Maybe not every week moving around, but you get the point. That the thing is that the skill sets they're building up can be used across the organization, and it's possible to pool resources and team together to solve problems as they come up. It also makes support much easier because engineers from one team should be able to go in and look at automation that was developed by another team and understand at a high level the structure and reasoning for how that was built. Now, this is also going to enable you to pre-build integrations into your automation platform. A great example is ServiceNow, source of truth like Nautabot, or telemetry capabilities that are built into the platform already. For a department to take advantage of those services, they don't need to go out and request their own integration with ServiceNow or build their own expertise on how to make calls in and out of ServiceNow. Those services are already available in the enterprise-wide platform, and it's much faster and easier for any of your departments to get on board and leverage those capabilities which were already pre-built into the platform. Now, the other real fundamental element to network automation is an accurate source of truth, a centralized information repository. A source of truth is one data store, where all of the old departmental data will be consolidated, cleaned, and verified to be accurate. Without accurate data, they say garbage in, garbage out. The automation needs good, accurate data to act upon and to update in order for the automation to be valid. Now, you could store any type of data in the source of truth: IP addresses, VLANs, ASNs, and so forth. It's really not limited by the type of data, but what we're trying to do is we need to have a centralized and authoritative source of truth. It's really required for accurate automation, and the quality of the data must be of the highest integrity. We need to replace all those manual Excel files that used to exist on the network share that kept track of IP addresses. How often did one person rename the file or save a new version of the file, and now you've got dueling copies that are out of sync, and it's very difficult to reconcile. We need to get away from those departmental data stores and have one centralized source of truth that unifies all those traditional departmental information repositories. Now, with this source of truth, it gives us one place to query the data. It also gives us one place for a person to go to make updates. So when an update is made, everybody sees the most recent version of that data, and they're not working off of out-of-date information. The last concept here is that a centralized source of truth, the reason it's really fundamental to network automation is we need to start separating intended state from the actual state. And we'll explain what that means here on the next slide. But without an accurate source of truth, we really wouldn't be able to separate this intended state away. Now, the next step on your network automation journey really ought to be to adopt an intent-based network management system. In a paradigm like this, we actually need to separate the intended or desired state that the engineers had planned to be deployed in the network from the actual configured state or the observed state that the telemetry and analytics system sees when it pulls the network. Too often when folks first start writing network automation, let's say they need to assign the next VIP or assign the next IP address, it's a common mistake to pull the network equipment to see what's configured on the network equipment and then start handing out IP addresses and VIPs from there. That's actually not a good practice to get into because you're starting to trust what's deployed in the network as the authoritative source when it may not be right. A better approach would be to separate intended state and desired state into a source of truth. Now, the big value to the enterprise is that we want to start auditing the network. We want to start comparing the actual intended state as stored in the source of truth with what's actually being pulled from the network. And if there's a mismatch, we want to know why. Either somebody has intentionally or unintentionally triggered a change in the network and it doesn't match what the engineers had designed, and we want to trigger automation or the orchestration engine to go in and push a correction to the network to bring things back into alignment. This can be helpful to the business for security audits, for config drift, a number of benefits that the business will realize from being able to separate intended state and actual state. Now, one of those, how often have your engineers gone out to troubleshoot a site, they pull up the documentation and realize it's several revisions, if not several years behind the last updates that were pushed to a site? If we can, again, quality data, good data in, good data out, if we've got great data on intended state and the source of truth, we could use automation to auto-generate printed documentation that the engineers could reference when they're troubleshooting a site. They don't need to manually keep updating that documentation. Just get the accurate intended state and the source of truth, and it enables automation to do all kinds of other heavy lifting for you that offers value to the business, and it saves time for your teams and makes them more effective. The next way that you can really drive business value with automation is to meet those users where they live. So for example, business users are often going through a service catalog like ServiceNow to make their most frequent service requests. If we can connect the automation with the underlying business requests, it makes everybody's lives easier. Rather than having a swivel chair where some engineer is assigned a service catalog ticket from ServiceNow to go and manually implement, many times they're taking that data from one system and swinging around and putting that data in another system to make changes. Why don't we just connect all that with automation, enable the self-service catalog to trigger the the automation that makes the changes with quality checks and assurances to make sure that it's a valid change being requested for the network, that it's within an allowable change for the given time window, or maybe it waits for the next change window. But the point here is that we can stage those changes or get those changes ready via automation much more efficiently and much more quickly by connecting automation to that self-service catalog. The other place where we really see a benefit by meeting users where they live are things like your network operations team, your support team. Chatbots have really proven to be a highly effective method for read-only automation to enable those support engineers to quickly either collect information about the network, collect information about a user to aid their troubleshooting. But many times we can even write automation scripts that automate the troubleshooting of an issue. User connectivity, wireless device connectivity. How many times in a month or in a quarter does your support desk troubleshoot wireless connectivity of a device? What if an automated script triggered by a chatbot could go out and query all the wireless devices, look at the last connectivity of that device, and help troubleshoot why that device might be having connectivity issues? So by enabling self-service, by connecting automation to these existing user interfaces that the users are already using anyway, they don't need to learn a new system. They're using the systems they're already familiar with to easily collect data by automation that's connected to these systems. Now, as you first start down your automation journey, perhaps one of the most frequently debated requirements for network automation is actually ruthless standardization. Now, what we mean by this is we've got to reduce the number of design permutations that are out there. Consider, for example, remote offices. We really ought to be able to sort those into a few highly repeatable versions, small, medium, large, t-shirt sizes, coffee cup sizes, that really start to enable repeatability and consistency in design. There's a lot of benefits to the business by pursuing this standardization. Fewer permutations of a design result in fewer variations and inconsistencies between copies. It allows simpler automation if there's fewer permutations that you need to discover. Now, simpler automation drives higher reliability. Higher reliability of automation drives confidence in that automation that it's going to work right every time. So it's a self-fulfilling prophecy or a snowball effect here that if the more we can standardize, the more we can bring things in line with our common coffee cup sizes here, the more successful our automation is going to be and the more scalable it will be as a solution. A shorter list of these variations will drive well understood designs that can be more frequently deployed, high repeatability, fewer backed out change windows. It honestly is a snowball effect of good things by driving to this standardization. Everything to documentation, operational support, troubleshooting are far simpler and may be aided by automation when we get to this end state. Now, granted, brownfield environments could have a number of variations that already exist that you're inheriting. This isn't going to happen overnight, but the trick is as you're going through network refreshes, as you're going through updates to these sites, those are opportunities and time windows when you can start to eliminate the outliers and start to bring things more in alignment with standardized designs, which will just make everything easier going forward after that. Now, many times adopting DevOps best practices include techniques like deploying a CI/CD pipeline. CI/CD stands for continuous integration, continuous deployment of changes. It also goes hand in hand with these modern development environments that separate development environment from test environment from the production environment. Really, the added benefit to your business is that we want to provide this segmentation to give developers a safe place to work in this dev environment without risk of causing any changes to the production environment. We don't want them touching any of the systems that are used in production. This CI/CD pipeline also enables automated quality checks. We want to make sure we have scrubbed all of the code before it ever gets promoted from development up to test into production. And we can actually enable automated testing to pre-check the code before it's pushed, check it post-deployment to make sure it's working as expected, and actually use automation to back out changes that might have failed on their way to deployment. All of this drives high consistency, high availability of the network for your users. And if something were to go sideways, we get those changes backed out quickly to get them back into a healthy state and minimize any impact that might still happen to the network as just the random laws of nature. We want to try and catch those changes early. If we can't catch them early, we want to get them backed out quickly. And these are some of the techniques that a modern dev environment would provide to allow you to do that. Now, last but certainly not least is something we mentioned all the way back in the beginning with DevOps environments, and that is building native telemetry analytics and reporting right into all of your software solutions. This is really foundational to modern DevOps techniques. Now, there's huge value in this to the business. For example, what about an ROI dashboard that every time an automation script runs to deploy a VLAN to a switch, we increment dollars saved or man hours saved, person hours saved for automation. Over the course of a month, a quarter, a year, you can actually produce tangible reports back to the business of actual savings in person hours required that used to be required to do these changes manually. The other thing is we can start to do trending of network performance over time. We can start to analyze how the health of the network may be changing to predict network outages or better help capacity planning down the road. The last point here is we can actually use historical trending to actually look at what the normal traffic patterns look like for a given time of year, maybe even the holiday season for a retailer, to improve our alarm selectiveness so that our alarms really are triggering on an actual out of norm event rather than an arbitrary alarm we maybe took a best guess at, but we didn't have historical data to base that on. Now with built-in telemetry analytics and reporting, we can make better informed decisions on where those alarm thresholds should be set. So a lot of value to the business by getting powerful insights and with telemetry analytics of what's happening within their network system and within their automation system as well. So finally, let's start to look at how we measure and predict value. What are the positive outcomes, the tangible positive outcomes that can be measured and verified to be delivered to your business through your investments in network automation? Now, all the topics that we've talked about in the previous slide are real tangible value that's delivered to the business via network automation. But many times businesses want to know, what are the hard metrics? What are the hard numbers? What are the key performance indicators that I want to look at to actually put metrics around the reliability increase, the operational efficiencies, how we're accelerating deployment of services, reduce costs. We need to see hard business metrics to show back to the investors, to show that we're actually making positive change, that we're in a better place than we were before these investments. The 15 metrics, the key performance indicators you see on this slide, are some of the most common ones that we've seen our clients use to document the gains of network automation for the business. Everything from total percentage of changes that are done via automation versus manual, reduction in fire drills, reduction in the number of emergency changes, reduction in the number of backed out changes, reduction in the number of incidents caused by change. All these are hard metrics that most large enterprises are already tracking to some degree. So they'll have a reference point of where they've been at up until this point with manual network management. So it gives you a great baseline for comparison of where the systems have improved once network automation starts to be deployed. And as you begin to accelerate your deployment of network automation along that journey, you can show how all of these metrics have improved as you've gone deeper into your network automation journey. Throughout our time here today, we've talked about a number of different ways in which network automation can drive tangible value to the business. A number of those are also summarized on this slide, including lower operational expenses, improved reliability and security, the increased ability to generate innovation and drive a positive business solution using IT as an asset, not just a liability, and able to get work done. The tools and techniques we've talked about have enabled your network management team to have greater insight and control of the network, better visibility of what's happening and why. And all of this is really meant to enable the business to get more work done more creatively, increase the agility of the business to develop new solutions, improve the time it takes to go to market. Really, for the first time, start to use IT in a meaningful way as a competitive differentiator against the other folks in your market. A number of the details underneath here illustrate the backup points of how those things are accomplished. But we really tried to hit on as many of those today as we could. We always welcome your feedback. This is just like in DevOps, our points here are always building an iterative approach to improve on the messaging. I thank you for your time today. I wish you all the best of luck in your own journeys, and love to hear from you. Thank you very much. Take care.